So we're given 2 points, and we have to find the exact value of the distance. The exact value means if it's some irrational radical, we are stuck with the radical notation. Decimals are not acceptable. Those are not exact values. Let's plot the 2 points first. 3, -6 is here, so that's A. And -3, 1 would be here. Okay. So there are 2 possible ways to do that. The first one is to recognize that the rectangular coordinate system has a lot of rectangles, which means there are lots of right angles. So it is very easy to find a right triangle where we happen to easily figure out the sides and then apply the Pythagorean theorem to find the hypotenuse. If the numbers are small enough, we can actually count it. Be careful that you're counting the line segments, not the points. So this is 1, 2, 3, 4, 5, 6. So this side is 6 units long. If you counted the points, you would be in trouble, because then it's 1, 2, 3, 4, 5, 6, 7, right? It's kind of weird. 2 points, 1 line segment. 3 points, 2 line segments. So there is a little bit of a mismatch. So you have to know what you're counting. This one is 7 long, which, by the way, if the numbers are too big, so we can no longer just count, just subtract the coordinates. If you subtract, let's see, A was 3, -6, and B was -3, 1. The horizontal side would be, what is the difference between the x coordinates? What is the difference between 3 and -3? When we subtract, we get 3 minus -3, that's 6. And the difference between the y coordinates, just find the smaller one and subtract from the bigger one. It's 1 minus -6, that's 7. So the difference between the y coordinates is here, the difference between the x coordinates is here, and now we're just going to apply the Pythagorean theorem. 6 squared plus 7 squared equals to x squared. So that means x squared is 36 plus 49. So that means that x is, algebraically, x is plus minus square root of 85, but of course, given that we are looking for a distance, we quickly rule out the negative one, and so the answer is just square root of 85. That's the exact value. Now that's one way. The other way, which is no different than this, is putting all these steps into one formula. Sometimes I make the joke that I come from a country that is so poor we don't even have the distance formula, and that is true. We just say apply the Pythagorean theorem, and that's the end of it. What happened here? So we apply the Pythagorean theorem to find the hypotenuse, right? How does that happen? We add and then take the square root of, and what do we add? The square of the horizontal side, which is the change between the x coordinates, and the vertical side, which is the change between the y coordinates, and that's going to be the distance. That is called the distance formula, and it's just putting all these steps together into one formula. Whether you prefer to use the formula or applying the Pythagorean theorem is up to you. I would have been troubled remembering where is the plus, where is the minus. So for me, just drawing a picture and applying the Pythagorean theorem is easier, but it's up to you which one you use. The problem is over. You can stop the video, but there is a comment about this. I just want to explain what's going on with this x2 minus x1. So if you look at the distance formula, what is this x2 minus x1? First of all, it doesn't matter, luckily, because if you subtract these two, you get either, in our case, if you subtract -3 from +3, you get +6. If you subtract it the other way around, you subtract 3 from -3, you get -6, which is not the distance, but who cares, because we're squaring it in the next step. So we're kind of generous with this, but then why 2 first and 1? We are usually counting 1, 2, 3. What is this x2 minus x1? So about that, I'd like to explain something, because this might be the first time that you see this x2 minus x1 business. So imagine the following. You have a younger brother, and on his birthday, you measure his height. It's a little ritual that you and your brother have. And say a year ago, when you first did this, your brother was 4 feet tall. That's the first measurement of the height, h of 1. That should be a 1 down here in the index. A year later, which would be the second measurement, h of 2, say your brother is 5.2 feet. How would you express the change? See, it makes sense to take the taller the larger number and subtract the smaller one, but that is usually when we express change, usually the later condition minus the earlier condition. So when you see this strange h2 minus h1 or y2 minus y1, that is the change. You will see a lot in physics. Change in temperature is always the second temperature minus the first temperature. Change in H. So change is expressed in this way, and that's what we see here. Of course, it doesn't matter because we square it right away in the distance formula. All right, that's it. Thank you for watching.